Hello, math friends. This is Mrs. Ruscio, and you are watching the Solving Quadratics by Factoring Day 1 notes video. Today, we're going to do some exciting stuff, as always. We are going to recognize the solutions to a quadratic equation, that they're the x-intercepts when y equals 0, or same thing as f of x equaling 0. We're going to find solutions, roots, zeros. They all mean the same thing of a quadratic function algebraically by factoring. So we're going to pull from unit 5. And then we're going to choose the appropriate factoring method with trinomials or GCF slash difference of two squares. All right, so let's get started. Number 1. So we just talked about in the top part here that we are going to be finding solutions, roots, and zeros, and all three of those words actually mean the same thing. So you're used to seeing roots and zeros. We are adding another piece onto this, solutions. So when we look at this graph, we can see this right here. On the graph, we have two solutions. We have two roots. We have two zeros. And remember how last unit, in unit 6, we were saying that it was such a big deal to write it as x equals -1 and x is equal to 1, 2, 3. We were saying x is so important, okay? We're going to find out why. Now, on the graphing calculator, we can do this very easily. We can go to the menu, analyze graph, and we're going to find zeros. And you're going to click, wiggle the mouse, and drag, and you're going to see that one of the zeros is at -1. Because there's two zeros, we have to do this process 2 times. And that's just another way. You're going to see, though, that these two are actually written as x-intercepts, which is kind of weird. It really should be written as x equals -1 and x equals 3. But we're smarter than our calculators, aren't we? Okay, number 2, we are going to solve each of these algebraically, okay? So what we're trying to do is we are trying to find the zeros algebraically. Algebraically means we have to show algebra. We're also trying to find the zeros, okay? Since we are finding the zeros, we are going to replace y with 0. So in my first equation here, we're going to write 0 is equal to x squared plus 5x minus 14. Now think back to unit 5 when we were factoring using the box. Many of you might want to show the box off to the side to factor. I think that there's a lot of us in here who are not using the box. So maybe in one of these examples, I'm not going to use the box to help me factor. But in any case, we have x squared. We have to make sure that they add up to 5x and then subtract or multiply to -14. So x times x is x squared. And I think my two numbers that multiply to 14 are 7 and 2, or 14 and 1. But I like 7, and I actually like 7 and -2 better because 7x minus 2x is equal to 5x. So what I just did here was I showed that 0 is equal to x plus 7 all times x minus 2. Now, if you think about math, you know that anything times 0 is 0. Yes, that's right. So 5 times 0 is 0. 20 times 0 is 0. Pig times 0 is still 0. It's not pig. Don't get confused. So if this whole thing here were 0, and this whole thing here were 0, this whole statement would equal that 0 that we're talking about here. So I'm going to create a little t-chart and just say if x plus 7 is equal to 0, the statement would be true. And if x minus 2 is equal to be 0, that statement would be true. So x is equal to -7 and x is equal to +2. And some of you be like, what did you just do, Mrs. Ruscio? Well, I just used my math brain, but some of you might say, can't you just show your work? Okay, fine. Take away 7 from both sides, take an x alone. Add 2 to both sides, take an x alone. And you want to know something really cool? This is why quadratic functions are so special. You must love them as much as I do. Okay, if you graph this, you're going to have a 0 at -7 and a 0 at +2. Draw this on your papers. Do it right now. Okay, good. All right, part B. So part B, this is looking a little weird because I'm so confused by this. It doesn't look like there is that last term. So sometimes when I see these things, I actually have noticed that this polynomial or this quadratic has two x's in common. OMG, this is a GCF question. So x can be factored out of both of these, and x plus 5 is left over. And we're still setting that equal to 0. Well, just like the example that we just did, we want each one of our factors, even though one of them looks a little bit lame, like this x looks lame, we're going to take both of our factors and set each of those equal to 0. X equals 0, well, that's easy. I love when that happens. And x plus 5 all equals 0. Check it out. I don't even have to do any math on the left-hand side. And over here, I'm going to subtract 5 from both sides, and I get my other solution at x equals negative 5. Okay, and remember, when we factor, we can either use a box or GCF. So I'm just going to write myself a little note here. You should do the same. This was a GCF question. Okay, the last piece of info that you might see as you're working on the practice, is that all three of these things mean the exact same thing. So some of you might be like, what? This is different than the directions in number 2 right up top here. It doesn't matter. It means the same exact